In physical quantities, the quantities that we measure, they are divided to scalar and vector. A scalar quantity will have only magnitude. A scalar quantity will have what? Only magnitude. Whereas a vector quantity will have magnitude and direction. Magnitude and direction. So when you have magnitude and direction, we call this as vector. When you have only magnitude, it's scalar. Example, as we discussed, when you have time, you're measuring time. Time is a perfect scalar quantity because there's no direction. But when you measure gravitational acceleration, the force of weight, it's always towards Earth, right? So that's a force because there is a direction for the force of weight. So that's a vector quantity. So if you see here, the examples, scalar, mass, distance, speed, length, temperature, density, all these are actually scalar quantities. What is a vector quantity? Weight, because the product of mass and gravitational acceleration. Gravitational acceleration will show direction, so it's a vector quantity. Displacement, how far is an object from its point of reference? So displacement will be a vector quantity. Velocity, rate of changes of displacement. If displacement is vector, velocity will be vector. Force, force is a push or a pull. So when you push an object forward, there's a direction. When you pull an object backward, there is a direction. So a force is a push or a pull where it's a vector quantity. Acceleration, rate of changes of velocity. As an object is moving in one direction, its velocity can increase or decrease. Acceleration is a vector quantity. Okay, rate of changes of momentum is acceleration. The formula is final velocity minus initial velocity over the time. Then we have the momentum itself, the product of mass and velocity. Velocity is vector, so the whole momentum is a vector quantity. What is momentum? The product of mass and velocity. Finally, we're going to look at two things today, distance and displacement. Distance always refers to how much ground an object has covered. You're walking from one point and you're going around, then you stop. Like you count your steps in your smartwatch, you count your distance you walked. Okay, I have completed 3 kilometers, so that's distance. But displacement is a vector quantity, how far an object is from a reference point. That's what we call displacement is all about. For example, if you see here, it's a very small field, right? Very small area to walk. Let's say here is 8 meters and here is 13 meters, all right? All it's like a perpendicular area. So also again 8 meters and here is 13 meters. If you start your journey somewhere here, let's say, okay, you started here and then you walked from here to here, A, you walked here 13 meters, then you walked 8 meters. So what is the total distance you have to walk? 13 plus 8, you have to walk 21 meters. You stopped at B now. So the distance you have covered is 21 meters. What is the displacement? A to B. You have to count the displacement. How far is the object from the reference point? Object is here, reference point. So how far is the object? Now you have to use Pythagoras. By using Pythagoras, you know what is the distance from A to B. That's what displacement is all about. Displacement is all about. So you know you have to use Pythagoras, AB squared. Now you have to use AB squared equals to 13 squared, you know, plus 8 squared. So you solve this, you get the AB. So this is how far is the object from the point of reference. If you continue to walk from B, then you came back to A. You are at the starting point where you started. Your displacement is 0 now because you came back to your point of reference. So distance, how far, okay? How much ground an object has covered. Displacement, how far an object is from a reference point, okay? So there's a huge difference between distance and displacement. Distance is a scalar quantity. Displacement is a vector quantity. Different, totally different.